You think cause comes before effect. That belief is why you think your choices matter, why you blame mistakes. Physics doesn't just question this, it removes it, and if cause and effect aren't fundamental, then the certainty you live by is something you invented. You don't misunderstand the universe, you misunderstand how much of your life rests on a story. You never learned causality, you absorbed it. Long before you knew the word, you were already using it. You dropped something, it fell. You touched fire, it burned. The sequence felt obvious, natural, unavoidable. So you stopped noticing it. You learned to think of the world as a line. First this, then that. A past that pushes. A future that responds. This feels so basic that questioning it sounds pointless, almost childish. Of course, causes come before effects. What else could reality do but notice something subtle? You never see causality. You see events, you see patterns. The because comes later. Your mind fills the gap automatically. It connects moments into a story that flows forward. It tells you this event made that one happen. This is efficient. It's also an assumption. Physics doesn't begin with causes. It begins with descriptions, relations, regularities. The certainty you feel about causality doesn't come from nature. It comes from repetition, from habit. When the pattern breaks, the confidence disappears. You call it coincidence, or randomness, or noise. But that reaction reveals something uncomfortable. Causality isn't a law you discovered, it's a rule you expect. And expectations can be wrong. You expect explanations to sound a certain way. You expect science to tell you why something happened, what caused it, what pushed it, what set it in motion. That expectation feels reasonable. It feels scientific. But it quietly collapses once physics gets serious. At a fundamental level, physics does not ask why. It asks what happened. And more precisely, what always happens together. Equations don't explain, they relate. They don't say this event caused that one. They say if this configuration exists, this other configuration exists too. The difference sounds small. It isn't. A cause is a story. A relation is a constraint. Feynman was blunt about this. When asked why nature behaves the way it does, he refused the press. Nature does not owe reasons. It only follows patterns. When physicists say they understand something, they don't mean they found its cause. They mean they found a rule that never seems to break. Gravity doesn't happen because masses attract. Masses simply obey an equation. The because is something humans add afterward. This is unsettling because it removes intention from the universe. No pushes, no triggers, no motivations, just structure. Once you see this, causality starts to look less like a law of reality and more like a translation your brain insists on using. And translations can distort. Feynman never attacked causality directly. He didn't need to. He simply stopped using it. When students asked him to explain why something happened, he often paused. Not because the question was deep, but because it was misplaced. Feynman understood that why smuggles in assumptions. It assumes intention. It assumes sequence. It assumes that nature works the way human explanations do. He rejected that instinct calmly, almost politely. For Feynman, physics was not about uncovering hidden causes. It was about describing what nature allows and forbids, what can happen together, what cannot. He compared physical laws to a chess game. The rules don't cause a move. They constrain every possible move. No square pushes another square. No piece forces the outcome. Yet the game unfolds with perfect consistency. This perspective quietly dissolves causality. Events don't happen because of other events. They happen because the rules permit them. Feynman was especially wary of explanations that felt satisfying. If something sounded intuitive, he suspected it. Nature, he insisted, does not share our intuitions. This is where discomfort enters. If causality isn't fundamental, then our explanations are metaphors, not mirrors. Useful, predictive, but not true in the way we assume. And once you accept that, common sense stops being a guide and starts being an obstacle. You assume time has a direction. Forward feels built in, past behind you, future ahead. So you expect the laws of physics to respect that order. They don't. At the deepest level, the equations are indifferent. They don't know which way time points. They work just as well backward. If you take a fundamental equation and reverse time, nothing breaks. Nothing complains. The math remains satisfied. This is where causality quietly dissolves. If causes truly came before effects, the laws would have to enforce that order. They don't. The equations describe entire situations at once. They relate states, not sequences. They don't say this happened, therefore that happened. They say these conditions coexist consistently. Time ordering is something you add later, something you infer from memory and records, not something the universe insists on. Feynman emphasized this without drama. He pointed out that physics doesn't run like a film strip. There is no preferred frame where now marches forward. From the equation's perspective, before and after are optional labels. This is deeply uncomfortable. Because if the laws don't care about sequence, then causality cannot be fundamental. It becomes a way of reading reality, not the mechanism that drives it. And once that door opens, the idea of an effect waiting for a cause starts to look like a story told after the fact. You are used to asking what caused something. When nothing obvious appears, you feel uneasy. An event without a trigger feels incomplete. Physics does not share this discomfort. At the smallest scales, things happen without asking permission from the past. No warning, no build-up, no identifiable push. An event appears, not because something demanded it, but because nothing forbade it. This is not chaos. It is structure without narrative. Feynman was careful here. He didn't describe these events as mysterious forces acting randomly. He described them as allowed outcomes, possible configurations realized. The difference matters. A cause explains why something had to happen. Permission only explains why it could. When nothing prevents an event, it doesn't need a cause. It only needs consistency with the rules. This is where everyday intuition fails completely. You expect the universe to behave like a machine, with gears pushing gears. Instead, it behaves like a system of constraints. Everything that happens fits. Nothing happens because it must. Once you accept this, the idea that every effect requires a cause starts to feel excessive. A demand for meaning where only structure exists. Reality doesn't ask for reasons. It simply occupies the space of what is allowed. And that realization removes another support you didn't know you were leaning on. By now, causality should feel less solid, not wrong in practice, but suspicious. So why does it feel unavoidable? Because your brain needs it. You are a prediction machine. You survive by expecting what comes next. Causality compresses the world into something manageable. It turns complexity into sequence. It turns correlation into responsibility. It tells you this led to that, so you can act faster next time. This is not truth-seeking, it's survival. Your brain doesn't care whether causality exists. It cares whether causality works. Feynman understood this divide. He warned against trusting intuition simply because it feels clear. Clarity is not accuracy. The mind edits reality aggressively. It erases simultaneity. It ignores alternatives that didn't happen. It stitches moments into a single thread and calls it explanation. Physics has no such needs. It doesn't simplify for comfort. It doesn't protect you from uncertainty. So when physics removes causality, it's not being perverse. It's being honest. What remains is a world too large to narrate, too structured to anthropomorphize, and too indifferent to fit inside your expectations. Causality is the handle your brain uses to carry reality. But reality is not shaped like a handle. Remove causality, and the universe does not collapse. It becomes quieter. No pushes. No triggers. No hidden hands moving pieces forward. Just a structure that exists all at once. Events don't line up into a story by themselves. They don't announce beginnings or endings. They simply fit together, or they don't. From this perspective, the universe is not happening to anything. It is not progressing toward anything. It is not explaining itself. It is simply consistent. Feynman hinted at this without ceremony. He accepted that the deepest descriptions of nature do not satisfy human questions. They replace them. When you stop asking what caused reality, you are left with something unsettling and elegant, a world that does not justify itself. Not because it is incomplete, but because justification was never part of its structure. Causality fades, and something stranger remains. A reality that does not unfold, a reality that does not persuade, a reality that does not care how it is understood. And in that silence, you are no longer looking at a chain of events. You are looking at existence without narration.